All right. For some reason, I thought for sure we had spoken about that really quickly before, but I guess not. Okay.
No, I do have a question. Sorry.
Sure.
Oh, 4 point, no. Wait. I think it's 4.1 set B, question 4, C and D. I just wasn't sure what a special factor is.
Oh, let me see. What's the context? 4.1, number 4, part section B.
Yeah.
Let's see.
I was gonna ask.
Yeah. So, in the context of 37 times 98. What do you think a special factor might reference? Let's see, where do they talk about? Well, let me ask you like this. We've done methods to do this. Does somebody know what method we would use to do this without having to write it the full algorithmic way? Yes?
The factor sheet and see what factor they have in common.
Oh, what factors they have in common? No. What is 98 really close to? That's a really awesome number to multiply by.
10.
90
Or
100.
100,
Five,
yes.
two.
So what are the best things to multiply by? 10, 100. They beat 2, they beat every number. And multiply by 10 is easy as shit. You just add a 0 on at the end, yes? Or you move the decimal if there's a decimal place. Yes, maybe?
Mm-hmm.
And that's all because your number system is based on 10. Oh. But that's not 100, is it? It's what? It's 100 minus 2. Cool. So then you can do this, right? Good old distribution. I like it. Now, they make a big deal out of 99, but who really cares? It doesn't really matter how far away from 100 it is. But the further it gets away, the worse this multiplication would be, right?
Would this be an associativity property that you were just doing?
No,
Or
this is distributed.
Distributive.
Yeah. I didn't move parentheses. I just brought the number in. Is that all right, guys? No? So again,
Yes.
if it's close to 10, close to 100, close to something like that, I could use this. I could say, so the way I would look at this, 98 37s is 100 37s take away 2 37s. So I wouldn't even think of it as distribution. But it's nice to write it like that, because that's what 98 is, 100 minus 2, and then you distribute. Now, would this be something that would come to you naturally, that you would think about? Probably not. And that's because a lot of times you don't get enough play time. That's going to sound weird. You don't get to play with numbers as much, right? In a certain context. But now that we know you could do this if you want to, you could start thinking about other things you could do. Yeah.
What's that called? Like that specific way of doing it?
Well, this is distributive property, but it's the special factor is what the book calls it.
Okay.
And they reference 99, but I mean, 99 is a special factor because it's 1 away from 100. So 98 is a special factor too. It's only 2 away from 100. So you can do this, and it still remains relatively easy to do. Yes.
For number 14, were we supposed to just give the answer for that one for the practice quiz? Or,
Well, I mean-
or did we just show that it's divisible by 6?
Well, what's it mean to be divisible by 6? Who remembers? Well, how can you tell if a number is divisible by 6? No, that's 4.
It goes 2 and 3.
Yes. So what's the rule for 2? What do you have to be to be divisible by 2?
Like 2.
You gotta be even. Is that number even? Yes.
Yes.
What's the rule for 3? What has to be true to be divisible by 3?
The sum of those numbers
The sum of all the digits
has to be multiple.
has to be multiple 3. So add up all the digits. You already know it's even. So you already know 2 goes in. So if 3 also goes in, then 6 goes in.
What about, but I did mine differently. I did the 6. I did this.
What'd you do? Let's see. All right, well, this is showing that 3 divides in. But what does this mean? Oh, this is still, all this does is shows that 3 goes in.
Yeah.
So why do you know 6 goes in?
We know that 6 goes in because when we add 6 plus 3, we get 9, and then 9.
Oh, no. So you can't, all right.
Because this is what I did with my tutor.
Well, that concerns me. So there's no rule about adding the number you think divides into it to some. There's no rule that says that, right?
Mm-hmm.
Okay. So it's just like we just said. So you did the work to show that 3 goes in.
Yes.
All you need to know now is, does 2 go in?
So
And of course, the number. What kind of number is that tells you 2 goes into it?
a 12.
What kind of numbers does 2 go into?
Oh, even number.
Yes. And is that an even number?
Yes, there's
There
an
you
even
go.
number at the end.
So you say it's even, so 2 goes in. All the digits add to a multiple of 3. So 3 goes in. Therefore, 6 goes in. You guys with me?
Yeah, because there's an even number at the end, so we know it's going to go in. And
Yeah.
and since we added all the numbers and there's a multiple of 3, then it will be 12.
Okay.
And that.
So one thing I want to make sure about, let me see. Does 6 divide 36?
Yes.
Yes. Does
Yes.
4 divide 36?
Yes.
All right, so 6 goes into 36, 4 goes into 36. Does that mean 24 goes into 36?
No.
Isn't that sort of what I just said, though? 2 goes into something and 3 goes into something means 6 goes into that thing. And we seemingly were all cool with what I just said because it's true. But why is that? Now stay with me. You guys understand the problem here? If 2 goes in and 3 goes in, then 2 times 3, 6 goes in.
Mm-hmm.
That makes sense. But if 6 goes in and 4 goes in, 24, 6 times 4, does not go in. Why not?
Because
There's actually a question on this other little extra sheet I had, but I might as well talk about it now.
that's because there's both an even number and odd numbers that don't really can go together.
What's true about 2 and 3
Factors of 6.
They're
and 6 and 4? Well, they're factors of 24, aren't they?
What's the lowest one?
Okay, maybe. What's true about 6 and 4? Do they share anything? Do they share any factors? They share a factor of 2.
They do.
What about 2 and 3? Do they share any factors?
No.
2 and
No,
3? I have no
they-
idea what this is, by the way. I'm just
They don't.
2 and 3. You can tell. Sorry. 2 and 3 don't share factors. All right, is everybody semi-still with me a little bit, please? A little bit, a little tiny bit. So
Well,
here's what's. Wait. 6 and 4 have 2 as a common factor. What's 6 times 4? 24. 24 does not go into 36, but 24 divided by the common factor does go into 36. So that's actually true, period. That is true all the time. So if one number goes into something and another number goes into something, their product doesn't necessarily go in. Their product divided by any common factors they have does go in. That's a neat thing.
so it's supposed to be true then.
So again,
So it's supposed to be true then?
what's supposed to be true?
Since you change the 24 and divide by 2, and then you make it into 12, and then you got the 36, and now
Well,
you have
12 goes into 36, but 24 doesn't.
Oh.
So here's the real thing. I want you guys to really understand this. Is this number, you can do it, Jeff. Yeah, there's a nice little number. I like it. Is that number even?
Yeah.
Yes. So it's divisible by 2.
Mm-hmm.
Is that number divisible by 3?
Yes.
No,
What's the check? How do you check?
because
Why
of the
is it
because of the
divisible?
Add the digits. What are the sum of the digits?
Yes.
12.
12. Is that divisible by 3?
Yes.
Yes.
So is this number divisible by 3?
Yes.
Yes. So the trick is, since they don't share, I don't know what this is still, since they don't share any factors, I could divide each one separately and they both work. They don't share any factors, so they're not kind of like getting in each other's way. 4 and 6 share factors. So if I divide by 4, there might not be a factor of 2 left over to have the 6 work. I have no idea if you guys are with me or not, but it's interesting. Yes?
What happens if you put like 4 numbers? Would you have to divide it by 4 instead of 3?
No, come on. The rule for 3, I don't care how many digits there are. There could be 80 zillion, even though zillion's not a number. There could be untold numbers of digits. As long as all the digits add up to a multiple of 3, 3 goes in. Yeah.
Because this is.
And we kind of proved it for 9. And once you prove it for 9, 3 just kind of follows immediately. I don't know if you guys remember, we actually proved the rule for 9. And you guys are like, we do so much shit in here, man. I don't know what we did. All right. You guys don't remember that, do you? Where there were the A's and the B's, yes? The A plus B plus C, yes? Okay.
Yeah.
Somebody's at least humoring me. No, just tell them yes and he'll keep going. Yes.
For number 4, I was wondering if I did that right. And then for number 1, are you gonna change the signs in the practice and in the real exam? The signs.
What signs?
The squiggly sign.
Oh, sure. Could be anything I want.
Like, could you give us an example, please?
Could be a star. It could be a triangle.
Oh,
could
but
be,
it would still be the same thing.
it would still be the same idea.
Okay, good,
Yeah.
good.
Yeah.
As long as it's still is the same idea. Because I was practicing a different idea by myself, and I did the minus instead.
Sure.
But
Okay.
But I know you could.
The
put it-
symbol itself doesn't matter. It's partially what we need to learn. The plus sign could have been the time sign. The time sign could have been the divide sign, right? Just sometime in history, we went, just use that symbol. And the one guy over there is like, let's not, and we killed him, because that's the way it was in the day. And then and that's the way it is, right?
So it just could be a star, but it has to be addition, and it has to follow the same idea
Well,
as it did.
okay. So it could be any symbol I want it to be, yeah. And I think the book uses different symbols in some of its homework problems.
And,
Yeah.
also, and this is number 4. I'm now talking about.
All right, so number 4 was this one. 25 goes into, man, do I have any good markers left? Let's find out. Goes into, what was it, C?
C,
Where'd it go?
it was 25, and then you put in the C, and then you put in the R, and then you put in the 22.
Okay.
Now we have to compute 25 times B.
Yes. And for the people that asked me about this last time, I said give yourself an example to remind yourself what the hell anything means, right? Because especially with long division, before this class, when's the last time you had ever done long division? Anybody?
Third grade.
Yeah.
Last May.
All right.
6th grade.
So we might need to do an example. Let's do an example for ourselves. What about 25 into 112? How does that work? 25 goes into 112 how many times?
4.
4. With how much left over?
12.
12. What's 4 times 25?
100.
100. Crazy shit. Which is how related to this. It's exactly 12 less than that, right? Yes? Do you guys see that?
No, I don't.
No.
I got 100.
It's impossible to not see that. Are we good with this? Are we good with this?
This is what I did.
No. Stay with me. Are you good with this?
All I know is that it gets into 4 remainder 12. That's it.
No, it's fine. Guys, real quick. So I gave myself a specific example with numbers I can really see, right? Do you understand how asking you what b times 25 is for this problem is the same as saying what is 4 times 25 for this problem? Yes? Yes?
Uh-huh.
Okay. So 4 times 25 is 100, yes? Right?
Uh-huh.
Okay. 4 times 25 is 100.
Yeah.
Which is how related to this?
4
How-
times.
How is 100 related to 112?
You minus, you plus 12.
So this is 112 minus 12.
Oh.
It's 100.
Oh.
You could do another example, but can't you see? And so what is b times 25 then?
What I did was the opposite. I did C over 25 equals b plus 22
Oh,
over
okay.
25. And then I moved the 22 over 25 into the other side so that b can be by itself. So I got c over 25 minus 22 over 25 equals b. But I know that
That'll
it
work.
it would be c minus 22 over 25 equals b. But
Well,
since
well,
I'm
no,
gonna
no,
get
no.
it by,
So
by
okay,
itself,
stop. Okay.
and again I did this with the
So
two.
what you did was you said, if this is true,
Can I write it down on the board?
you said if this is true, then C. What'd you say now?
I said c.
Whoa.
I said c over
Yeah,
25
C divided by 25 is
equals
B plus 22 over 25.
Yes.
Alright, so stop. Big problem with that is we haven't introduced officially in this class the way to rewrite remainders as fractional parts, right? But there's not a damn thing wrong with doing it this way. There really isn't. I mean, that's really what this means, right? How would you write this? Wouldn't you write this as 4 and 12 25ths? So then 112 divided by 25 equals 4 plus 12 25ths is exactly what you're writing, yes? But it's sort of like not really what we want to see at this point. But I mean, all you have to do here is multiply everything by 25 and then subtract 22, and then there you go. 25 times b is c minus 22.
Yeah, that's what I got.
That's exactly what we get here also. B times 25 must be the thing inside minus the remainder. Done. Less work even. Okay.
Wait, it goes 25b. 25b, yeah. Wait, so 25b equals c minus 22.
Totally.
Okay, because
Which is what you get your way also.
because originally I just put equals c minus 22.
Yeah, that's the answer.
Oh, okay. Good.
Yeah,
But would it be-
25b is c minus 22.
But would it be okay if I did it like that on the exam?
If I ask you a question exactly like that, maybe. It would be fun, because we do know fractions. We just haven't talked about them in our class yet.
Can you give us another practice one, number one?
Yes. So, let's see, let's keep that there. I want to remember that they're here. So if I wanted to do a quick little let's just use a normal symbol here just for now. Boom, boom. And what do you do, Jeff? Let's say it's not a lot here. Let's do one word. All right, so then I could say C, A, B, A, C, B, say B, A, C. Let's see what happens here. B, A, C. Why not? That's really funky. Okay. Is this closed? Yes, totally, because what are the only elements we know?
ABC.
ABC, and when I operate with this, do I get anything other than ABC? No, so it's closed. I like it. So what is C plus A?
Is
B.
B.
Totally, right? C plus A is B. I like it. So what is C plus A plus B?
You start with the parentheses first, so you start with A plus B, and that would be A.
Yep, A plus B is A,
And
right?
then you do C plus A,
Which
which
we
would
already
be
know
B.
is B. All right, is everybody cool?
Yeah, so it's
I like
just gonna be something like that in the
Totally.
exam.
Now let me ask you this real quick. Let me see.
Ooh.
Is this commutative?
He's saying that
Is this commutative?
No.
Can you show me an example that shows me it's not commutative? In fact, I really want you guys to realize if you look like this, don't know if you guys understand what I'm saying. Like C plus A equals A plus C, is that true?
Yes.
Yes, C plus A is B, A plus C is B. But what is C plus B?
C plus B is A,
Is A, and what's B plus C?
and B plus C is B.
B plus C
Oh,
is
yeah, it's a B.
B. So is it commutative?
No.
No. I like it.
Oh.
So that's another example of a question I could ask you. Yes.
Ooh,
If it's not commutative, couldn't you end up with the wrong answer if you looked at it in the wrong order?
Yeah, so how?
Totally, yeah, so you gotta look at it the right way.
So it's less,
So
so
what is the
Way
correct way?
So,
way.
the right way is the way we've been doing. The right way is, if I say A plus B, that's it. A plus B,
oh, I've
bam.
been doing
Oh, I've
the
been doing
other
the
way.
opposite.
Yeah,
What
me
the
too.
heck?
Bam.
I usually read from top and then the.
Oh, so you've been lucky that I think of, enough of the problems in the homework happen to be commutative. But there's a right way to do this, because commutative property is not just given to you. So, alright,
I learned it look from the top and then the side, so I unlearn
Okay.
everything now.
I'm sorry, buddy, that was wrong. Whoever told you that. But the real thing is, it almost doesn't matter. You could design it so you could look here and then there. But it would still end up not being commutative, correct? I like it. But, like somebody just pointed out, we're gonna look here and then there. So it's gonna be like B plus C, bam. C plus B, bam.
You're not lucky.
Just to make sure we're consistent with ourselves. Is that cool?
Yeah.
So,
Okay. So again, is that our number system?
No,
no.
Hell no!
I hope not.
Our number system don't have no B in it. Alright. So does it have to operate like our number system does?
Yes. No.
No. It's not our number system, so it doesn't need to operate like ours does. In fact, have you guys ever heard of matrices?
Kind of
A matrix?
system.
Maybe
You know, not like there is no spoon, but
it's pretty ancient to me.
matrices looks like this.
Oh, I hated those. Those were like what, Math 135?
Yes, yeah, I think
Or no.
we could do them in there if we wanted to.
Or
Yes.
Math
in
110.
math 125?
Oh
Say
no, Math 110.
120 is what I thought you were meant.
Yeah.
Well, 110, yeah, 110 you could do with matrices. Alright, if you've never heard of them, it's okay, but that is a beautiful example of multiplication not being commutative. Right? But that's a good point you brought up. You gotta know what's the official way to look at this, or else I'm gonna give you the wrong answer. I totally get that. So it's this first and then this. So it's row first and then column. Okay, I like it. Okay.
So for number 2, do you have to look for the perimeters or just the lengths?
No, well, how are you gonna end up with the length? You're gonna have to figure out what the perimeter is for each situation, right? And on number 2, what's telling you how many situations there are? How do you figure out how many situations there are to look at for number 2? What do you have to do with 72? So you know the area is 72.
Factor, right?
Factor it. Because I also told you, for some reason, this is a very, very obsessive compulsive person. All their stuff has to be whole number dimensions. Yes? So they're like, I want a 72 area, but it could be as long as it's whole number. So like 8 and 9. That's a situation. So then you got to stop and think, okay, if it was 8 by 9, what would the perimeter be? Done with that situation. Next situation, what's another way to factor 72? And you keep going until you're exhausted, either physically, mentally, or you're exhausted all the options.
All of the above.
Because I just did the lengths. Like,
Okay, so 2 and 36 is one situation. It could be 2 by 36. What is the perimeter in that case?
that'll be 36 plus 36 plus 2.
Yes, you have to do that for each pair of factors.
And I have to do it for perimeter. So I just put lengths and perimeters.
Yeah, so the lengths that give you the right area and what perimeter that would lead to.
Oh, okay.
Yeah.
Every perimeter and every length. Got it.
So then if they're trying to save money, you can figure out which factoring pair makes you have to buy the least amount of fencing, right? For example. And in general, the shape that makes you take, if you're having a rectangular shape, the shape that has you do the least fencing to have the same area is a square. That's always true in general.
Also, for 3b times 5, power of 5 in expanded form, without the exponents, would it be 3b times 3b times 3b times 3b times 3b?
Yep.
Or would it be 3 times b, 3 times b, 3 times b, 3 times b, 3 times b?
So you said the same thing twice.
Well, I did it more like...
I'm with you. What does 3b mean?
Well, 3b means is...
What does
combined.
3b mean?
One whole number?
No, what does 3b mean?
Not
Does it mean 3 plus b? Does it mean 3 minus b? What does 3b mean?
multiply?
Yes. So 3b, 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 3 is the same as 3 times 3, 3 times b, 3 times b, 3 times b. It's hard to say. Do you understand what I'm saying?
Yeah.
So if you don't put the time symbol, it's the same thing,
Oh.
right? A letter sitting next to a number means multiply.
Oh, so it's the same thing. Okay.
So that's why I meant you said the same thing twice.
Oh,
Yes.
okay.
5, okay.
And then for number 5, I got 0.
Oh. What does it have to contain? What is the additive identity? This is number 5, by the way. What does it have to contain? 0. What's the multiplicative identity? 1. Now, and it's got to be closed under multiplication.
0 times 0 equals 0.
And 0 times 1 is?
0.
And 1 times 0 is?
0.
And 1 times 1 is?
0.
0.
1.
1.
Whoa.
You got first.
I wasn't even trying, but I'm going to retroactively say I got you. So do I need to introduce any more symbols to make it closed?
No.
It's already closed, right? You guys understand? So you gave it the things it needed, 0 and 1. It's got to be in there. And then you step in and you go, do I need anything else? Is there anything I get that isn't in there now so that it's not closed? No. 0 and 1 generate 0 and 1 when I multiply them any way I can, so I've got everything I need. It's closed.
Yeah.
Does that make sense?
That makes sense.
I like it.
So then, what would you give an example problem for number 5? If you were going to change it.
I could change the operation. There's one in the homework that's sort of like this, like it said 17, I can't remember. So what would you have to add? If I wanted to make it closed under addition, same problem. 0, 1. If I wanted it closed under addition, what do I have to add? To 0, 1. Is that enough? 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is... Shit! Do we have 2 in there? Okay, let's add 2. All right, now let's recheck. 1 plus 2 is... Oh, shit. So, of course, just extrapolate. What are you going to have to add?
At 3.
Well, then when you add 3, you've got to add 4.
And
And then
it's
you
gonna
add
be-
4, you got to add 5. And
It's going to be endless.
you got to add 8 when you add 4, because 4 plus 4 is 8. So, I mean, what do I have to add then?
Dot, dot, dot.
All of the
I would just say dot, dot, dot.
whole numbers. All the rest of the whole numbers
All
have
the
to be
rest
added.
All the rest of the whole number.
If I want it closed under addition, shit, I got to add everything. I got to all the whole. If I want to close on location, 0, 1, that's all it needs. Because it doesn't, I like this word, by the way, it doesn't generate any more elements than it already has. But under addition, it generates stuff it doesn't have. I have to put them in there. I'm like, damn it, and it just grows to crazy. Okay?
And will it be for number 3? For it says complete the addition table. Do we have to use in the exam? Is it going to be a subtraction table or is it just going to be an addition table?
It could be a times table.
A times. Can we work on that one together? A times table.
Yeah, I think there was one in the homework, wasn't there, for like a different base?
There was, but that one took long.
I wouldn't make it that big. I probably-
3.2.
3.2?
I don't know. There's base something.
It was in the book, I think.
3.2.
Yeah, 3.2 talks about
And 11.
multiplication.
It was number 11, I think.
3.2b, 11a.
It was in
How many?
Look at that teamwork.
base A.
Yeah,
You can do it.
base 8.
There you go.
Kick ass. If I did give you one like that, I'd probably give you base 4 or something smaller, more contained. I think there was a problem where you had to do like 200 something times 80 something or something.
Whoa.
Anyway, let me give you this. Let me give you the answer key. You guys can check. See if I got these right. Did I do that?
No, I did. For, I have a question.
Yeah.
For number 6, do you want us to explain as well? Or is that just what you do?
Well, it said, what would you say to that student?
Oh.
Yeah.
No, for us it says just write it without, it doesn't say.
It didn't say, what would you say to that student?
No. It
For
just
number
says-
6?
Oh,
It's the number
sorry.
7's on the back.
Oh, 7 on the back.
7?
Sorry, I got mixed up.
Oh, I'm sorry, yeah, I gave myself some more room on some of these when I did the answer key, yeah. That's my bad. Again, I keep inadvertently hitting people, I'm sorry. It's crazy. So see how I answered number 13, for example? So there's sort of an infinite number of possible answers there, but they're all the same idea.
So for number 14, you are saying yes, it is. So 6 is a factor of 3, 5, 1, 7.
Yes. Now, of course, what could you do on your own? You could take your calculator, divide it by 6, and see if it goes in anymore if you want to.
You
Yes.
show your work, I guess.
For number 8, could another explanation be like you can only do it because it's the same base, it's like grouping variables together, so like a different base would be.
Say it one more time.
That's pretty.
Good.
Wait.
19.
Oh, the last one for 19? He did 4.
Oh, it
How does it
is.
work? It does work.
I did 10 and 9.
I did too.
I think
And
you're
then I
thinking-
got, because that also.
Oh, I see. Oh, but so you make the connection between you.
So we can.
You're adding how many the base you have, so the bases shouldn't change. I like that explanation too. Yeah.
For number 19, I got 10 plus 9.
That's fine.
Okay, I don't know, you just had to.
There's just another possible answer, yeah.
We were even sure.
As long as you have two composite numbers.
I'm trying to say you guys too, but.
I got
the same answer.
Started off as 3, and we did 5.
She got.
Opposite of prime, so they factor into more than just one of themselves. So 3 is a prime because it's 1 times 3 only. 4 is not a prime because it's 1 times 4 and 2 times 2. So that's
Oh,
composite.
what now?
Anything that's not prime is composite.
Well, that's good. Oh, not in set A. You said 4.1, right?
Yeah.
Okay. And then what number did you say again?
Number 32.
Okay. No, you have to like multiply these 7.
That's smart.
I don't think I did that this way.
You put whatever is on.
No, it's such a big number. You have.
What number?
4.1B 32 or 36?
32.
Oh,
And 32.
well, you just have a.
41B 30.
777.
Yeah, it's
32.
0.7, it's times 10 to the 17th power. For that, he said he could take it either way.
Yeah,
It's
that one
such
is
a
being a
long
little
number.
lenient on because your calculators probably won't show you the entire thing. But part of the question was really, can you figure out a way to do it so you can get all the
You
digits?
multiply both of the numbers though.
Say again.
You multiply both of the numbers though, right?
Yeah, you multiply those numbers and then it's too much for your
And then
calculator.
you probably could do, well, for scientific notation, it's just adding the rest of the zeros.
Okay.
I don't know.
Sorry. Yeah, but if you put it in the calculator, it's probably gonna be too much for the screen of your calculator to handle.
For 36, I think I got calculator overload and I had to just break
For
it
what?
down.
For
Oh,
what?
calculator overflow. I think it was 36 and I had a 36. Huh? Yeah, I did. Yeah.
One has to multiply that, one mental calculator, so with flash. That times 81 is that. So I multiply that. Oh, sure, whatever, man. So, yeah, if you try to do 123 business times 80 business, it might overflow your calculator, right?
Uh-huh.
Okay. But you could instead, you could do 123 business divided by 81 times the other dude, just to see if the approach would work. Does that make any sense what I'm saying? So if you had to do 4 times 8 divided by, so, alright, if you had to do 10 times 4 divided by 5, right? 10 times 4 divided by 5. Can't you do 10 divided by 5 and then multiply by 4? Totally you can,
Okay.
totally. Alright, real quick, why am I allowed to do that?
Because I don't know.
So 10 times 4, what's another way to write divided by 5?
The under thing.
Yeah, times 1/5. Now can't I multiply things in any order I want to? If it's just multiplication, yes?
Yeah.
So then I would do 10 times 1/5, which is 2, times 4 is 8. So what I'm saying is, in your calculator, you could do the 1, 2, 3 big ass number, right? Divided by 81, and then multiply by the 80 big ass number. See if it will handle that. Because if you cut it down by 81 first, it might not overflow at the end. Yeah, those human calculators kind of creep me out a little bit. Mostly just because it's like, what have you decided to do with your life? And I can do a lot of stuff in my head, but I'm no human calculator for damn sure.
You sure?
I'm really sure. I mean, did you see that problem they're talking about?
Yeah.
I can't do that shit in my head. I don't want to.
Can you go back? I don't know. The 4-point question that was confusing me. This one. No, not that one. I don't know where it went.
Alright, find it.
Oh, here. There we go. It's just the special factor one.
Oh, yeah. So what's wrong?
I just can't figure out how to do the division was.
Oh, this one.
Yeah.
So, okay. 5 is a special factor, but it has its own way to act.
Okay.
When you want to divide by 5, do you guys know? How do you divide by 5 easily? Any number? Do you guys? Isn't it easier? Isn't it easy to divide by 10?
Yes.
Okay. So if I, for example, if I had to do 42 divided by 5. If I double 5, it becomes 10. I better double this at the same time. And then 84 divided by 10 is 8.4. Move the decimal back once, right? So I really, and watch, what am I doing? What's 42 divided by 5? Isn't it this?
Yeah.
Isn't that 42 divided by 5? Can't I double the top and bottom? Because that's what we do with fractions. Yes? That's why 5 is a special factor, because there's one thing I can do to make dividing by it easy. Easier. You guys hear about that plane crash up in Santee?
Yep.
Yeah.
Yes.
I live near there-ish. I live next to West Hills, but not
Yeah.
Santee.
Was it? There's a few people that died.
UPS driver.
Yeah, and unfortunately, I wish I could, somebody posted a video of it, and of course I saw it before I really, it's like, I didn't really wanna see that. But somebody caught the video of the plane actually crashing. You know, one of those porch things?
Oh, the rain.
Yeah.
Cameras.
Yeah.
When the cameras put up on the porch?
Yeah.
Yeah. And then you stop and think, man, how many times do I hear a plane going overhead? It's like,
Yeah.
damn. Alright, so let me do this. Let me give you this. Some of you guys have things you're looking through, and some of you don't. So let me give you this. It's just a little extra stuff to think about if you want to. And then we will discuss. And if you'd rather just focus on like homework or something, you can just ignore this.
More.
Anytime.
What?
What?
Now, the funny thing is, alright, so number one, we sort of talked about that before, a little bit, this idea. I just wanted to see what you guys came up with, if you remember what we talked about when we talked about tipping stuff. Number two is really interesting because when you guys become teachers, you're gonna see so much creative, different ways to be wrong about something. It's gonna be amazing. But so often, the way that a student is wrong is really interesting. And you have to kind of, you know, say, this is kind of a cool idea you had. It doesn't work because of this, but continue trying some new stuff out, right? Because part of the job, especially in the early math education as a teacher, is just being sort of a check on, you know, what's gonna work, but allowing them to be really creative with what they're trying to do. So number two is interesting. I've actually, well, I mean, I don't teach that too often. I did teach math 88 before, where we basically do learn this, but I don't think I've ever seen this mistake before. So part of your job as a teacher is to try to really understand the mistakes your students have made and not just sort of like cross through it. Now, some of you guys might say, well, Jeff, I've seen you grade my homework and you just cross through my shit. I'm like, yeah, you're not in third grade anymore, but,
We are,
huh?
just like we are, we're learning third grade math.
I know, but, are we really, you know, I know, but I just want to say real quick, you know we're not learning third grade math, we're learning the ideas behind it. I mean, every now and again, we're talking about base 16, hello. Yeah. Go ahead and try those out if you want to, and then we'll talk about them. And if you have questions on other things, you can ask away. You doing homework or something else? If you have other questions besides this paper, you can continue asking them. Does somebody have a method for that first one?
10% is really easy to find, you just move the decimal over, so it's 4.7, and then to get the 5%, to make 15, you just divide the 10% by 2, and add them together.
So, cool, I love it. I think we sort of talked about that as a method. 10% is easy, like she said, just move the decimal back once. Now, what could you do first with $47.31?
You could round it.
Yeah, either to 48, or you can make it a 50. And of course, you would be more likely to round up if your service was good, right? You can round it up. So yeah, 10%. If I made it 50, 10% would be $5. 5% is half of that, so $2.50. So overall, I would leave $7.50 as a tip. Cool. Anybody else? Is there a different way? Anybody thought about? No, no, okay.
No.
Here's one other way. So, oh yeah, did you have one? Okay. I'm gonna have to multiply those, right? 0.15 times 47.31, yes? So I can make 0.15, 0.20. Let me put it up on the board. So if I've gotta do 15% of 47.31, I could do 20% of 45. So that's 0.2 times 45.
Did you give us a new sheet?
Yeah.
No, I
You guys kind of with me? If anybody's listening?
I didn't get the new sheet, you guys.
Oh,
were-
hold on. So 2 times 45 is 90, so 0.2 would be 9. So it'd be $9. I can leave $9. Where's the, oh. Just a little extra if you didn't have anything else you wanted to look at right now. I mean, that's just one other way that came to mind to do it. I mean, the nice thing, so 10% of something is easy because you move the decimal back once. 20% of something is easy because you move the decimal back and then double it. Yes? If 10% is move the decimal back, 20% is move the decimal back and double it. So 20% of 45 is 4.5 doubled, $9 Done. Yes, maybe? I just want somebody to put down, I'd get out my calculator. Brenda? Brenda, come. Brenda. What do you guys think about number 2?
What, how did that happen?
Okay.
Well, I know he borrowed unnecessarily.
Good. All right, so one big problem that you want to directly address is the unnecessary borrowing, right? And that really threw things off. Big time.
Ended up in
That's actually the,
thousands.
yeah, so, like, what's the first problem? 179 minus 26. Okay. So what the student did, let me make sure I get this incorrect the right way, is they borrowed when they didn't need to. And you can imagine, the thing is, you're going to be working with students at such a level that you've forgotten what it was like not knowing how to do this. So your brain can't see it, but they understand borrowing. They know they're supposed to borrow. This student obviously didn't connect when they were supposed to. Now, what would they do next? What does anyone see how they got the answer they did?
Yeah. Wait, what?
They did 19 minus 6.
19 minus 6.
And put 13 down below, and then they did 16 minus 2.
Yeah.
You messed up, or they messed up with the place values.
Okay, good, I like it. There's a place value issue. You can't put 13 into one place, right? But they don't necessarily understand that. How could you show them a method to know so they could tell they're really off, that their answer is nowhere near? So remember, the original problem was
Adding.
179 minus 26. So what could you tell them?
Why are you in the thousands place?
Okay, good.
Well, first you have.
But don't, why are you in the thousand? Well, you're not going to say that. Come on, kid, what's your problem? Yes, sorry.
Probably give them an example, like if you had 179 apples and you gave away 26, how do you get 1,000?
Yes, exactly. Good. Yes, I love it. So not only just stick in the realm of pure math, saying, it should be less than, but actually having a physical thing they can consider. If you had 179 apples and you ate 26 of them, how would you have 1,000 something left over? That so at least in the future they have a way of identifying when their answer completely makes no sense, so they know they did something really wrong. So that's another thing that estimation is used for. So I could estimate the answer, right? I could say like 180 minus 30. Right? But then the student has an issue with borrowing incorrectly, but 180 minus 30, they might not even have to think about it like this. They could just think 180 minus 30, 150. It depends on what level they are. Okay, maybe. So what's a little bit challenging for you is to do that last one using their incorrect method. So trust me, it's one of the most interesting parts of the job as a math teacher is to really try to understand when a student makes a mistake, what did they think the right rules were, right? Because if you don't think about it like that, you can't fully explain to them what went wrong if you can't really get in their head, which is why I'm big about showing me work, man. If you don't show me work, I can't get in your head at all, which makes it really hard for me to explain if something goes wrong. Okay. Are there materials you could use, maybe that we've used?
Base 10 blocks.
There you go, some
And
base
then
10 blocks.
strategy could be the
Flats and some longs and some little dudes. I like it.
Also the ladder strategy, because of the place values.
Yeah, you'd want to focus on place values for sure. So there's a few different directions you can go because it seems to be multiple different ideas that the student doesn't understand. The fact that 13 can't be in one place, right? And that is a really weird idea when you don't know the number system, which nobody is born knowing. So you guys just don't remember. I don't remember either. I'm not saying I remember. I don't remember either.
These are just problems that we're just.
These are problems that I could actually ask you on this next test. So I'm not just going to give you something to occupy your time. These are things I could ask you.
We barely just went over 50%. And then for number 2, I don't get it.
Right up here, right? This is going to be a huge part of your job as a teacher, is meeting a student where they're at. And if you don't understand the mistakes they're making and the thought process they were using, you can't meet them where they're at, right? So I understand this is one of the most interesting parts because it's one of the most challenging parts. My God, every level of math, I have students doing things and I'm like, there seems to be logic here, But, so I gotta really stop and go, and really try to be them for a minute and see, what were you thinking? What did you think it worked like? Okay, so, Andrea,
Yes?
do you notice, so this is the problem, right?
Yeah, that's.
Do I need to borrow?
No, you don't.
Did they borrow?
Yes, they borrowed.
Okay, so what you need to understand is, this is somebody who's learning this for the first time, right? They're gonna make mistakes.
Yeah,
So
It
you're
was-
trying to figure out,
it was unnecessary borrowing.
totally, no, they did this. Then what's 19 minus 6?
19 minus 6 is 13.
13, see they put the 13 there? You see that?
Mm-hmm.
And then they just did 6 minus 2,
You got 4.
and then 1 comes down.
1.
So that's what they got. So that's what they did wrong. You could look at the next example and see they did basically the same thing.
Unnecessary borrowing.
More unnecessary borrowing. And then if you look, you need to try to do that 486 minus 72 as if you're that student using that incorrect method.
If I was a student, but I was
If you were that student doing the same wrong method, can you do it that way for the last problem? You're going to get the wrong answer, but that's not what matters. Do you really understand the faulty logic they were using? If you do, you should be able to replicate it.
This is what they basically were doing.
So let's see. 16, okay. Yeah, there you go. There, you got it. Perfect.
Then how did you do number 1?
What do you mean?
I just got back from the.
Oh, the tip one?
Yeah.
Oh,
Yeah, like,
so you could do
no
this.
zeros.
15%
So that's the problem, right?
They're
of
wrong.
47.31.
That's the problem.
Uh-huh.
Then you could round. If I round this up, I've got to round this down.
'Cause they-
That'd be 45, yeah.
So you could do 20% of 45.
12.
Of
12 there.
45. And then you get 9.
9.
12.
Or the more direct way, you could round this to 50,
The 50.
right? Round it to 50 is a nice whole number. And we did this before. 10% of 50. To do 10% of anything, you just move the decimal back once, yes? So that would be 5. So then what's 5% of 50? If 10% of 50 is 5, what's 5% of 50?
So 5% 50, so.
Oh, no, stop, no calculator. So
That'd
if
be,
10% is 5,
that'd be 100. Cause 0 to, I'm sorry,
no, watch.
to 2,500, so 250.
250. Because it's gonna be half, isn't 5 half of 10?
Uh-huh.
So 5% of this is gonna be half of what 10% was. So then you get a tip of 750.
What the, how did you get 750?
Well, 10% is 5, 5% is 250, so what's 15%? Add them.
Oh,
Doesn't that give you 15 total percent?
yeah.
It's kinda nice how percentages work that way.
Yeah, I kinda like the first part better, the,
Okay, yeah, that's what I would do, and your waiter would like that way better, because look, I gave them a whole $1.50 extra. Not too bad.
Could you also multiply, round up to 48 and multiply it by 0.10?
Yeah, that would be a lower estimate, yeah. Because then you would be rounding this by a lot relative to what it was, and you would only round this up by very little. So I would at least take this up to 50, but even then you're getting $5, which they'd be like, thanks so much.
Yeah, someone sent me $10 yesterday and they only got like 3 things.
Oh, I don't know what that means. I mean,
No,
were
I
the
work
3
in the
things
sa-
cheap, I guess?
No, I work as a sales photographer and they're like 13 if you buy 2 or more. So like 39?
And they gave you $10?
Yeah.
Not bad, it's 25% tip. I had a friend who worked at a restaurant, and she just had, I remember she took a book off her shelf, and she opened it, and there were just these $20 bills just in there that she was pressing, and I'm like, because she was making stupid tips. I mean, it was rib place, and they served alcohol. So you'd have all these businessmen come in after these meetings, and they just chow on ribs like, "Here you go, young lady," they're just throwing money. And she's just like, I was like, "We're going to lunch, and you're buying."
It was,
Your money just for dropping out of books. I'm like,
it was in Seaport Village. Oh,
Yeah.
the restaurant I was stationed at, and there's a lot of conventions at the Honda Center.
there you
I
go.
don't know.
There you go. You get those
Business.
business guys who are drinking something. That's some good tips. Good tips. Yes.
Number 28 on 4.2 set A.
22?
28.
28. Okay. Yeah. So the duplication algorithm. Blah 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 blah. Let's see. 28 by 36, repeatedly doubled. Stops when the next power of 2 is greater than the number by which, so you're doing 28 times 36. So what they're doing is they're doubling 36. So they did it 16 times, because the next one would be 32. Right? This is more than 28. That's why you want to stop there. Let's see what else they do. Here we want 28 of the 36s, and since 28 is 16 plus 8 plus 4. Yeah. So what you do, let me do a smaller example, just to really make sure we understand. Let's say I wanted to do, what do you got, Jeff? 18 times 23, right? So then you double it, 2 times 23, 46, right? 4 times 23, 92. Let me make sure I do it the same way. Well, I mean, they had 1. What do you do? 1 times 23 is 23. 8 times 23. I just keep doubling every step. Is that cool? Double, double. So I'm going to double this.
Like a double.
Double, double. Bubble, bubble. Something I can't remember. All right. You with me so far? And I'm doing 18, so by the time I get to 16, I want to stop. But how do I make 18? Isn't 18 2 plus 16? So then 46 plus 368 is the answer. 2 of these plus 16 of these is 18 of these, yes? That's the method of doubling. Is that not better? What's up?
Yeah.
You sure? You don't? Okay. All right. It's actually kind of a neat method. You kind of build the parts. It's the same way we did 15%. If I know 10 and I know 5, I add them, I know 15. If I know 2 of them, if I know 16 of them, I add them, I know 18 of them. No? You guys, anybody agree with me? That's kind of neat? You don't have to.
I do.
I'm not going to fail you if you say no. Okay.
Wait, why did you get 18 times 23? I don't know what problem.
Because that's the problem. So I made up a problem, 18 times 23. So the method, this doubling method, you double 23, and then you double it again, and you double it again, and you double it again. Then how do I make 18? Isn't 18 2 plus 16?
Yes.
So the 18 times 23 is 46 plus 368. You can check. What is that? 4 something. I don't know.
What
414?
problem is that?
Is that what that is?
What problem is that?
This is one I made up, but it's related to number 28 in 4.2 A. So today is sort of contingent on what you guys want to look at.
For the exam?
Yeah, let me ask you real quick. Anybody working on number 3 on this at all?
I was working on
I
numbers.
was.
Do you?
I did number 3 already, but I of course, when you said addition table, will it be an addition?
Oh, no, I'm talking about this extra thing.
I
Oh,
didn't.
no.
I mean, can you sum up the mistake the student was making?
I just thought he wasn't considering the ones place
Any clue?
because
Sure, yes.
I'm still writing it down.
When I
I'm
was
sorry.
doing
I was
3A, I
writing
got.
it.
in the
They
100
give you, I'm sorry, real quick, Andrea, in that problem, they give you an example of their own. I just gave another example, right? So in the problem, they give you another example.
Which problem was it?
28, 42A.
Oh, I already did that.
Okay. Let me come back. So, one way to do this is to do the problem yourself. And this is a mistake I've seen. So I can kind of relate to this. So what is the, if I just start long dividing this, don't even look at your paper anymore. Just do the problem. 3 is crazy. But you guys, please tell me you know better. I'm going to bring the 2 down, right?
Yeah.
Before I bring the 9 down, what should I do? Does anyone know?
I don't know.
Add 0.
Yes. Why? Real quick. I really want this to make sense. Let me see. What if it was this? Real quick. Hold on. Everybody stay with me. What if it was this? What if it was this? Almost the same, right? Just added 200. Stay with me now. 4 goes into 14. Thanks, everybody. Then you bring the 2 down. Do I bring the 9 down also right now? Of course I don't. Of course I don't. 4 goes into 22. Okay, thanks, everybody.
Huh?
7, 28, 1 remaining. Okay, now, so watch. When we get to this point, 4 goes into 2 how many times?
0.
No times. Then you can bring the 9 down.
Oh,
Okay.
I did that ever when I.
Oh shit. You did. It's just been forever.
No, actually, it was in 6th grade. No, I mean, it was in May, in 2020. 2020
Really?
May. I was working with a 6th grade class, and they were doing things like this, or like they had it, you know.
It might have just never happened because it's got to be where this goes into this part evenly.
Yeah, I don't
Right?
know why. I maybe just never registered
Okay.
in my brain.
But you can kind of tell there's a problem because that R is over the last digit, right? And I think that's the first thing you picked up on.
Yeah.
Do you guys understand what I mean? Do you see the R like is over the 9? That's not the way it should work, right?
No.
And it's because they forgot to add that 0 in. Now, what the hell does this mean? Use compatible number estimation for part A to check the reasonableness of each of the students' answers.
Well, for what I did, I just did an easy number. I went down
Yeah.
to 1200 because that went into even. That went.
Well,
even
no.
below ones.
So watch this. So if their answer, they did this, what was it, 37, remainder 1. If this was correct, then 37 times 4 should be close to this, yes?
Oh.
So that's what that means. Can you use estimation to see if the answer makes sense? Well, if the division was done correctly, then that means the answer I got times the thing I divided by should be close to this. And of course, you can do like 40 times 4. What's 40 times 4? What's 40 times 4? 160, which is nowhere near this, right? That's an obvious mistake. Are you guys understanding at all? Somebody?
Yes.
That's what I mean by using estimation to make sure that, to show that there's no way in hell it could be correct. Sort of like what we did with the student that was subtracting incorrectly. You start with 176 and you take some away. How the hell can you have 1,000 something after that? I wish that's the way money worked, for example. Yes?
A question on 4.1, problem set B, number 4, C and D left B.
4-1-B,
And then problem number 4.
4.
Last 2 on C and
Oh yeah. 37 times 98 I had up here earlier. 98 is really close to 100, right? So you can do this kind of thing. And then distribute. That one makes that easier. So 98 37s is 100 37s. Take away 2 37s, which is really the idea.
Can you go over number 3 again? I fell asleep.
Well, that's a choice. That's too bad. Okay. So number 3.
It was on number 3A.
Is it 3 on the other sheet we're talking about?
Yeah, the other sheet we're talking about.
All right.
Sorry.
So this time, stay with me. Was it 4?
It was 4.
So what you do is you just try to long divide it so you can compare to what the student did, right?
Yeah.
So
And then
4 goes into 12 how many times?
3.
3. You would bring the 2 down.
Uh-huh.
4 goes into 2.
None.
No times. Then you can bring the 9 down. That's the mistake the student made, right? They
Yes.
forgot to add that 0 in the middle
So they keep forgetting the zeros.
every time.
And now it says, use compatible numbers estimation to check the reasonability of each student of the answer.
Yes. So if I divide, if the student got this, Andrea, the student got that. If that was the right answer,
If that was the right answer.
if that was the right answer, what should 37 times 4 be close to? No, stop. I don't want to know what it is. What should it be close to?
30.
Look. 4 goes into 20 how many times?
5.
Because 5 times 4 is
20.
20. Yes? Okay. If 4 goes into 1229 about 37 times, then shouldn't 37 times
36.
4 be close to this?
Yes.
All right. So what is 37 times 4? Can't you do 40 times 4?
Yeah, and that would be 80.
No.
Wait, I'm sorry. 1,006.
160.
Yeah.
Is that anywhere near 1229?
No.
Okay. So that's using estimation to see that your answer, or the student's answer, is really far off. Because you don't get anywhere near the number inside.
Oh, okay. And then describe the pattern using why might be he using such a procedure? He keeps forgetting. He keeps
Yeah.
forgetting
The
to
0.
the 0 because he brings
He
up-
just did. I don't know why.
he
I've
did-
seen it happen. I've seen that exact mistake happen.
He brings the 2 numbers instead of 1 number.
Exactly. Because each time you bring a number now, you should go over a place.
He brings in 2 numbers instead of 1 at a time.
Exactly. And, you know, he's got to. He has to bring down 2 because that's the only way 4 can go in. But each time you bring a number down, you're supposed to go over a place. That's why we put a 0 down if it won't go in, because now we got to go over a place.
Oh. How would I do it like in, I don't know if you're going to change, you said the addition table, so are you going to say addition table in the exam, or are you going to change it?
Oh, yeah, I think it was originally addition, and I wanted to change the symbol just to get a freakier symbol, because I'm pretty sure the book had a little triangle somewhere.
Oh, okay.
Or
so
we
just-
did it on an earlier worksheet.
So we're just going to do, you're just going to say
Use the
addition.
following table or something if you want to use a different symbol.
It's
Yeah.
a different symbol, so it's just going to say, follow the same idea.
Yes.
And now for number 3, you said addition table. What if
Yes.
are you going to change addition table to multiplication table?
I could.
Oh, so can you help me with that? I was struggling to do the homework.
So if I had to do a base 4
So you have to do a,
multiplication table, right? So if I had to do this, let me give myself some room.
multiplication table. 0, 1, 2, 3, and then.
All right, so this is pretty. So these are kind of silly. But oh well, right? 0 times anything is 0.
Uh-huh.
And of course, 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. And that's going to happen here also, right? 1 times 2 is 2, 3 times 1 is 3. Okay, so you can grab the ones that are straightforward.
And then the 2 times 2 is 1, 0.
Good.
And then the 3 times 2 is 11.
11.
Well,
Sure.
3 times 2 is 6.
So every time, now watch, I really want this to make sense. The 2's table is going to go by 2's. So 2, another 2 is 4, which is 10. And what's another 2? 12.
12.
because this goes by 2s. This one goes by 3s.
3,
So that's 3, the next one's gotta be 6.
6, yeah.
But what's 6 look like in base 4? 1, 4, and 2 1s.
I
right?
can barely hear. I can hear other students talking.
Yeah, we're all studying though.
Yeah.
So watch this, another thing you use, 2 times 3 is 12, isn't it?
Yes.
So what's 3 times 2?
So 3 times 2 is 6.
No. Base 4.
So that'll be
2
12.
times 3 is 12.
So won't that be 12?
3 times 2 must also be 12, exactly.
But now 4 times 3, 4, 8, 12.
No, 3 times 3,
Well, 3 times 3 is 9.
which would look like what in base 4?
So 9 times 4,
No.
or 9 times, or 9 plus 4.
So, all right.
I'm lost.
Yeah. So 2 times 3 is 6, which is 1, 4, and 2 1s. 3 times 3 is 9, which is how many 4s? 9 is how many 4s?
9.
How many 4s going in the 9? 4 goes into 9 how many times?
4 goes into 9 by 2 times.
2 times. With what left over?
1.
There. Hey, back. So sometimes you can use commutativity, right? Sometimes you can use, so there's commutativity right there again. But then here you gotta just think 3 times 3 is 9, what's 9 in base 4?
But then how if, so it says to use the table to find, so let me help you.
I've got it. Okay. So what's your question?
So it's gonna be asking me for 3b, like per se base 4.
So I could say, what is 12 base 4 divided by 2 base 4?
12 base 4 divided by 2 base 4. So I'm gonna have
Look
to,
at your table.
so
Just look at the table.
12 base 4 divided by 2 base 4. 10?
No.
I'm looking at it wrong, so how would I do 2? So
Now watch, Andrew. What is 15 divided by 3?
that's 5.
Because 3 times 5 is 15, yes?
Yeah.
So use the missing factor approach. What 2 base 4 times what is 12 base 4? Wouldn't that be the answer to this? 2 base 4 times what is 12 base 4?
4 was 3.
3. Done. So this is equal to 3 base 4.
3 base 4. Oh, is there another one you can give me?
They're all the same. I mean, this is not really big enough to do much with, but like, what do you got, Jeff? I don't know. What's 10 base 4 divided by
Okay, so.
2 base 4?
By 2 base 4.
Can you see it in the table?
Yeah. By 2.
2 base 4. Yeah.
2 base 4. Oh, okay. And so it's gonna be either.
Once you get the table created, division problems are easy as long as you think of them in terms of multiplication, because that's what the table's all about. So 10 base 4 divided by 2 base 4 means 2 base 4 times what is 10 base 4? So then I can find it real easy in the chart.
So you can either use an addition table or a multiplication table.
Well, yeah, I could ask you to create either one I want to, but then all the questions have to be, if it's an addition table, I can ask addition and subtraction questions. If it's a multiplication table, I can ask multiplication division questions. Yeah.
And multiplication. Can you give me a multiplication problem?
Well, I mean, the multiplication problem would be really straightforward. Well, let me ask you this. What is 1 base 4 times 2 base 4 times 3 base 4?
Times 3 base 4. So 1 base 4, that's 1 base 4, and 2 times 4, that'd be 2. That'd be 2 base 4, so 2 base 4 times 3 base 4, so 2 base 4 times 3 base 4, that'd be 12 base 4.
There.
Oh.
I mean, once you get the table created, The questions need to be relatively simple. It's just, can you look at the table correctly, right?
Okay, so is it gonna be a subtraction table?
Well, there's no subtraction table. It would be an addition table that I can ask subtraction questions about. So like this problem, didn't I ask? Yeah. See? I asked subtraction problems because you made an addition. So 12 base 7 minus 4. So 4 base 7 plus what? Is 12, 5 base 7.
Yeah, okay.
So if I know all the additions, I automatically know all the subtractions. Yes?
Yes.
Okay.
Ooh, good. Gladys, can you go over number 13? If you were going to ask a question for 13, how would you rewrite it? Possibly, because I
don't know.
13 was a bit hard for me.
Well, I could ask you, here's a simpler question. Let me see. If A divides X and A divides Y, does A divide XY?
A divided by X and A divided by X.
Not divide by, divides.
Divides. And A divides Y. What does A divides X, Y?
Yeah, if this is true and this is true, does this hold? Does this work?
Yes?
Okay, then you have to explain why.
Yes, because I have to do an example, won't I?
Now you have to prove it, which kind of is more work than
Oh.
counterexample, right?
Darn it. How would I prove that? I just presumed yes, because if it can go into AX and
So you
then-
could try, yeah, you could write me a few sentences and explain it. That could work. Yes.
if if A can go into X, right?
So,
If
hey, everybody, remind me real quick. What does it mean if A divides X? What is that? Does somebody remember what that? Sorry?
A goes into X.
All right,
doesn't
good.
it
Now,
go
how can
into
I
factor?
rewrite it more specifically? If A goes into X,
That means A times something.
A times something is X.
Oh, hang on.
If A divides Y,
A times something goes into Y,
right? So do we have an expression for X?
it'll be A, B, C.
So this, does A divide, so what's XY then? XY would equal ABAC,
Uh-huh.
which is also known as A squared BC. Is that cool?
Which will also be,
Does A divide this?
yes,
Why is it obvious that A divides this?
because there are two A's,
Because A is a factor of this.
because A is a factor.
There you go. That would be the proof you would show. So it almost sucks if the statement is true, because that means it requires a proof. If the statement is false, that's awesome. I just have to find one counterexample, like we did on the practice test.
That makes a nice sound. Like compatible? Explain what compatible means, because it says together makes a nice sound number.
Which one?
Number 10. You said compatible numbers, and you also did the same thing for number
Yeah.
19.
But what's 62 plus 38?
62 times 30 plus
Plus.
30 plus 38 is 100.
Those are compatible numbers. They make a nice round number. So I would add those first.
Oh, okay.
Yeah. Oh yeah, so the way to do this nice, it's a totally different approach than this for 5. Because if I double both of these, then I'm divided by 10. Yeah. So it's a very different approach. 5 has its own approach.
No.
Things that are close to 10 or 100 have their own approach. Yeah.
You'll figure this out.
Oh yeah. Number 4 on this extra sheet is the problem we talked about earlier. I think it's exactly the problem. Yeah.
Oh,
What's up? Sorry.
I wasn't.
Okay. I never know what to do with a response like that.
So funny.
I know.
Smile
You guys are? I'm just gonna. When you ask me a question sometime in the future, I'm just gonna laugh at it. Mr. Well, I need some help in there. Anybody else? Yes.
Can you go over number 4? I wasn't here.
Oh, okay. See, this is the, alright. So in the future, Andrea, you gotta bring everything you need with you. You don't wanna miss any part of the lecture.
Yeah.
So remember the problem we did where it's divisible by 2 because it was even?
Yeah.
And it was divisible by 3 because they added up to be a multiple of 3.
Uh-huh.
So, and I said, since 2 divided it and 3 divided it, then 6 divided it. Remember, that's what the point with that problem was. It was number, or where was that problem? I can't remember. Was that in the homework?
No.
Oh, it was one of mine, wasn't it? Yeah, there, number 14. So, that works. The problem now is, if 4 divides something and 6 divides something, that does not mean 24 divides it.
It's not. Why not?
Because they both have a factor of 2.
They both have a factor.
So I really want this to make sense. If I divide it by 4, I'm dividing 2 multiples of 2. There might not be a multiple 2 left over for the 6 to work. So here's something really cool. If a number is divisible by 2 different numbers, it is divisible by the product divided by the common factor. What do 4 and 6 have in common? 2.
2,
right?
yeah.
So 4 times 6 divided by 2 is 12. 12 will go into the number.
But
24 won't necessarily go in.
Only 12 can go, but not 24 because they both have a.
Because they both have a factor of 2.
They both have a factor of 2.
Yes. It's kind of related to LCD.
Least common denominator.
Yeah, it's a little bit related to that, but not directly.
Ooh. And I'm gonna have to do, let's say, 12 base 7 plus 4 7. So if I were looking at that, like 12 7 plus 4. So I would.
No, I didn't ask you. Plus, did I?
No, but I'm making it up. You
Oh,
know.
well, do like 3 base 7 plus 4 base 7.
Okay, so.
That's going to be something that lives in the chart.
So 3 base 7 plus 4 base 7, you said?
Yeah. See, that'll be a very easy question because
So 3 base 7 here plus 4. That's 1, 2, 3, 4, 10 base 7.
see, so any question I ask you that's addition, of course it's going to be super easy because the table shows you all the additions. That's why I'm going to ask you about subtractions and stuff.
Subtraction.
Because then you have to kind of think backwards using the table. But it's still there in the table, you just have to think backwards.
Gotcha.
It's the more interesting question. Or I might ask you a question like this. Write this down. 2 base 7
2 base 7
plus,
plus
parentheses, 3 base 7
3 base 7.
plus 5 base 7.
So I'll start with the parentheses first. So that's the 3, and then I do 1, 2, 3, 4, 5. No, it'd be 11.
Okay?
11 base 7.
I made it 2 base. Plus 2 base 7.
Plus
Yeah.
2 base 7, so
That's not in there, so I made it 2 base.
yeah.
Anyway, you get the idea. I could give you a problem you got to do in a couple steps. But they should all be in the table. Yeah.
All be in the table. What would be another question that you could give for number 5? Because I got 0, but I never thought it would be 1.
Oh, like I said earlier, I could have said closed under addition. Well, it's got to be 1, Andrea, because I said the multiplicative identity has to be in there, and that is 1.
Oh,
So it's got to be at least 0 and 1. The whole question is, do I need anything else in there?
No.
No, because it's already closed.
It's already
But if I said closed under addition,
closed under addition.
is 0, comma 1 closed under addition?
No, because no. It's
1
not.
plus 1 is
1 plus 1 is 1, and then 1 plus 2
1 plus 1 is
a 2.
2, so it needs a 2.
It needs a 2, but it's gonna.
But the
keep
minute you put a 2 in, it needs a.
It's gonna need a 3. It's gonna
3
need
and a
4.
four,
It's gonna
yeah.
go keep going forever. It's
So
gonna
you
go
have
dot,
to
dot, dot,
add
dot.
all of the whole numbers.
You have to
Yeah.
add all of the whole numbers. If it's under addition, means you add all of the numbers in the element. No, in the set.
Oh, yeah.
Numbers
So the whole thing is, if only one of the statements is true. So what you have to do is assume the first statement is true and see if that could possibly work. You do it until you get one that could be true, and it wouldn't make anything else, and then the other ones would be false, correct?
My question is, where's Bob's out?
Say again?
Where's Bob's out?
That's a good point. I mean, well, also nobody's accusing him, so it's kind of like balances out. Yeah. But I don't know, we're not gonna look at it from a CSI perspective. What questions should the detectives have asked? We don't know, we just got that.
So I said close under addition. So I said close under addition means all numbers. That means all the whole numbers have to be in the element or the same set.
All the whole numbers have to be in the set, yeah. That's the only way it could be closed. You guys can, you guys are, alright. I mean, goodness, look at you. If you're ready for the test, get out of here. Stop staring at me.
What do you think of my practice problems I made with the tutor so far?
The test is only on 3 and 4, right? Chapter 3 and 4?
And 5-1.
And 5-1, okay.
Yeah, so I just made 5-2 for next time.
Okay.
Yep.
What do you think of my practice problems? I made some of them myself, along with the tutor.
Okay.
Wednesday, I gotta run some.
Okay. Just be really, just like I said, you gotta understand, I'm not gonna ask you the exact same questions.
Yeah, no, not the exact same. That's what I'm trying to do. Make different problems, and that's why you do the addition table.
And some multiplication,
and
exactly,
multiplication and
exactly.
multiplication.
Yeah,
Exactly.
nobody answers.
I got.
Thank you.
Oh, by the way, I have a little thing